All right, at the end of the last video in problem 7, we saw that if we changed from a counterclockwise parameterization to a clockwise parameterization for our circle, this gave rise to corresponding flux integrals that were equal but opposite. Okay, and that's an illustration of a more general principle that I wanted to discuss in this video. So to start, let's say I have this curve C here in blue, and I parameterize the curve in such a way that as I move along the curve, the interior region that's bounded by our path is to our left. Okay, so if you imagine you're walking along some path that surrounds a body of water, say a pond. Okay, then as you move along that path, the water is always off to your left. Okay, so if I parameterize the curve this way, I'm then going to go ahead and compute corresponding circulation and flux integrals, and I will get some values. Okay. Now, what happens if I reverse orientation? So in other words, instead of moving along the curve this way, so the interior is always off to the left, what if it's now off to our right? Okay, so as I move along this way, notice the uh, the tangent and normal vectors are just the opposites of what they are up here. So now, right, these unit normal vectors point inwards as opposed to outwards, okay? And for this force vector F, okay, what's happening to the angle now between F and T and N? Well, if I compare, say, uh, this force vector right here to the same force vector down here, but look how it's um, position now relative to the tangent and normal vectors, see the angles now are going to be supplements of one another. Okay, by replacing t with negative t and replacing n with negative n, but keeping f fixed, okay, the dot products here with f and t and f and n are going to be the opposites of what they are up there. So the punchline, of course, then is just that by changing this parameterization, so by reversing orientation in this way, okay, we're going to get circulation and flux integrals that are equal but opposite. Okay, now in question 7, the circulation integral was 0. Okay, so if you reverse orientation, you could say that you're going to get the opposite of 0, but that of course is still 0. But with the flux integral, okay, that was what, 2 pi a squared. So then we got negative 2 pi a squared for that reversed orientation parameterization. All right, cool. Well, I'll see you in the next video. Thanks.